Hello and welcome to the IDS Vision channel, How to 3D. I'm Ute and I'm working for 6 years now for the Ensenso customers at IDS to help them with their support questions and with their pre- and after-sales issues. What I want to show you today is how in about 50 minutes set up the Ensenso camera for getting first colored 3D data. What I did before here is connecting the power supply and the data cable to the camera. That's all explained in the manual. I've did it before and I put the data cable to the computer. And now I want to show you how to start with the settings on your computer to establish the network connection between your camera and your PC. So if you open the network settings, you open the network adapter here and make sure you have a fixed IP address entered here. Then you can, in the advanced options, check some settings. So make sure you have the receive buffer set to its maximum. You disable energy efficient Ethernet. And you want to set the jumbo packets to its maximum, and that's the 3 main settings. So you find them in the Ensenso manual. I can send you the I will link the address in the video. So once this is done, the settings, then you can open NXView. And NXView is the graphical user interface that you use to set up all the parameters you need to get good 3D data. Here you see that the IP address from the camera is not yet in the network of the computer, and you can use the network wizard to fix this issue. It's pretty easy. Just select the camera and the network wizard does its job. Takes some seconds because the camera has to be reopened. Now you're asked, is it correct? You see your camera and select it, say yes. And then you see here is the list where all available cameras are listed. You have the 3D and the color camera. It's both inside this housing. They are listed separately here, so you can decide to open just the stereo camera, but we want to open it as a bundle. And to make sure that I show you the things that you will see if you first time open the camera, I do a right click and I can select open with default settings. This is what you get every time you open the camera when there is no data stored. So every time you open the camera from your application, you will get an opening with default settings. So I just stop the acquisition and show you what you see here. So here is the control area. You can start live mode. You can do a snapshot, and this is to open the parameters. We get there later. Here you can select whether you have a look at the color camera or you look into the stereo camera. So we start with the camera images, for example. Here is what the stereo camera sees. This is what the color camera sees. And what you do with NXView is mainly set the parameters, save them, and then you are ready to start in your application by loading those parameter files, and you have the settings that you choose in here to be the best one for your application. So we have here 3D data. and the depth data. And we want to start with setting the color camera. So I let it run, choose the image, and for the color image, it's mainly about setting the exposure time. This can be done here in the parameters window. So there is the things you know from RGB cameras. You have the option for automatic exposure. It's chosen here, and I reduce the exposure time to have a good image quality that I want to see. I check it here in the viewer, so you see it's immediately applied to the 3D data, and I see the mandarins are nice orange. Just can reduce the exposure time a little bit. And when I'm fine with my 2D image, I save the parameter file just by clicking here on the Save button. Choose a folder and save the 2D parameters. And that's it for the RGB image. Now I select the stereo camera, and there are some options more. The first thing you want to see, we want to have a look at, is the presets. This is a bunch of parameters that you usually have to set, and Optonic put them into nice presets to make it easier to get the settings that you want to achieve. So they are sorted from left to right with higher acquisition rate and lower 3D quality to slower acquisition rate and higher quality. So this one is called dynamic scenes because it's suitable if you have moving objects, and that requires a very short exposure time. And if you have static objects, you can use the time for making higher quality images with more image pairs, and this is you would choose this setup. What I recommend is here choose the patch match presets. This is a more current stereo matching algorithm, and it's the best benefit in my experience between time and data quality. So for example, let's take the patch match with 4 flex view images. What you see here, you can have a look at the frame time. Now we have 4 flex view images. Flex view image is a mechanism that improves data quality by capturing several image pairs. In this case, 4 image pairs, and this would result in a frame rate of 2.6 frames per second here. If I choose 8 image pairs for the data acquisition, the frame rate decreases to 1.3 frames per second. So this also gives you immediately an idea about what you will get with these settings. And if we look at the 3D data, for example, here, I show you here with a single shot, you see frame rate increases up to 5, but you see here the edges are a bit blurred. And if you go to the higher quality, you see that the edges of your 3D data will get sharper. So then, if you're done with the rough settings, you can check your 3D data quality. I show you here just stop the acquisition and enlarge that window. In the 3D viewer, you get a lot of information. So here you see the coordinate system. This is the origin of all the 3D data you see in the point cloud. And in default settings, the origin is in the left stereo camera. So the grid here shows you the Z0 plane. And if you look into the depth image, and I go to point cloud to get 3D values, you see here the Z value is roughly 1 meter. So, and now there is one thing you want to do in your application. Regularly, you don't want to have the 3D data in a coordinate system that is inside the camera. Maybe you want to have the 3D data transformed to your scene. For example, in this case, I show you how to transform the coordinate system to the floor by just removing the objects and take an image from the floor. Thanks. I make a new image here. So this is the 3D data of the floor, and we can just reduce the area here a little bit. And now I show you how to set the coordinate system's origin down to the floor. So first I go here to the workspace calibration and choose align plane with depth data. And then I go to start. And to make it visible, I go back to the depth window again. So you see the grid moved from the camera to the floor. So here it's nicely aligned with the floor. And if we put the object back again, it's magic. Just in place. Then I go to the depth data here, and you see here the Z value is around 0. This has an advantage that if you want to remove the background of your scene, so if it's a conveyor belt or a box or whatever, you just can choose the values that you want to keep, the points that you want to keep by their set value, and this makes it much more easy to delete points from the point cloud that you don't want to have. And this is the next step I want to show you. Usually an optical 3D system provides you much more points than you actually need, and I show you some easy steps to reduce the number of points. So what I've already used here are these markers where I can just set an AOI. Just stop it here. And you can go as well to the Set AOI button, use the sliders here. And you can choose to clip this parity map to specified area. This means that your 3D data will contain only the points that are within the Set AOI. So this reduce the points in the area in the first step, and we can also reduce points in the depth. To do this, we go back to the parameters window and to the stereo matching, and we can limit the depth range. To show this, I go here back to that image, and you see what happens. You get that blue box that you can extend to the values you need. So I started with the maximum distance, and here I use this. Then you see here this is farther away from the camera, so it's at the moment not included. I have to choose a larger value, and I can just edit here, for example, this. So it's close to the goal, and here I can choose the depth range here. Then if it's too small, then you see the object will be cut. So I choose this setting, and then I'm fine for the first step. Some final settings you can still do is if you have some noisy data, speckles, artifacts, whatever, you can use this parameter, speckle region size. This will delete every cluster of 3D points that contains less than 150 points. So I can just set it to a large value, and here the data is quite good, so you don't see very much happening. But in some cases you have here like small snowflakes everywhere, and then you can delete this using the speckle region size slider. Okay, and then when you're finished and you have set up 2D and 3D data, you go to save the 3D parameters as well. And then you're done. So now if you close the camera and open it again, you just could load these values. I can show you. Close the camera. I open it again with default settings. And then I select stereo camera, load parameters. I choose load link as well, because the link is the workspace transformation, so that transformation from my camera coordinate system to the workspace we've just set. I apply this and I change to the color camera, load the parameters. And I'm done. And one a really great advantage of that software is that you now can, for example, imagine IDS provided you a lone camera for 2 weeks, and you can just collect data from your objects and from your scenes, and you want to try different exposure times, or you want to try different camera positions or whatever to find out which settings provides you different data qualities. You can save the camera images. So basically it's about those images and the parameters that has been used for computing the 3D data. And then you can open it as a file camera and work offline. So if you have to return the camera, you can just use the file camera to work with it, or you can provide that data to your software development and they can do their software development without having a hardware camera. So you just would go to File, Save, Raw Images As, and yeah, I did it before. You have the oranges, and I can show you if I close it. I have a file camera here from some other objects that I can open. And you see it's a completely different setup. And I can still work on it. I can view the 3D data. And I can still do post-processing here on the 3D data. So of course I can't change the image quality, but I still can change the post-processing. I have to select. So in the file camera, it's easy to distinguish between color and stereo camera. So this is the wrong one. This is the stereo camera. And here you have the options to still do some post-processing on that data. That's it. I hope to prove you how easy it is to set up an Ensenso C camera for getting colored 3D data and store all the relevant data that you later need to set up your application. Have a good day and bye-bye.